today in this talk, I really wanted to go over what it means to secure the blockchain in a continuous basis. Of course, we've all heard about getting the audit. Of course, insurance is a huge part of that. But as developers, the question comes down to us. What can we do to kind of go ahead and protect our protocols, protect our contracts? And that's what I just wanted to go over at a highest level in this talk today. To give you a bit of background on myself, I'm the CEO and co-founder at Guardrail. It's a real-time security monitoring platform for the blockchain. And of course, when we're talking about security monitoring, that's a huge part of DevSecOps. So this is something that I spent a lot of time thinking about. And what I wanted to do today is share some of the learnings that we've seen working with teams across the space, just to bring to you guys what is the best that the best teams are doing. So given the audience today, it's going to be a mix of developers, security, maybe amateurs and security experts. I didn't want to go too deep into a specific area. So today we'll be going through a bunch of different realms of security. And then I'm happy to pick up this conversation offline and talk to any of you guys on any of the areas that are most relevant. With that being said, let's dive right in. This is a rough agenda. We'll just be going over what DevSecOps is, how it relates to crypto, and then a framework for how I like to think about DevSecOps in the space. And then we'll wrap up with some concluding thoughts. With that, let's dive right in. So first of all, some of you guys might be wondering, what is DevSecOps? It may be a confusing term. It may be something that you haven't heard of before. So to simplify it, really it's just DevOps and security put together. Pretty simple. Now, some of you guys might be thinking, okay, that's taking an easy way out. So what's the reason behind DevSecOps entirely? The reason that we're even talking about this at all is that over the last decade, the way we ship code and the way that applications are building are changing pretty rapidly, especially in blockchain, but even in the broader Web2 ecosystem. The cadence of deployments is growing very rapidly. This means that there isn't a feature freeze or a security testing time once a quarter. Now code is being written every day. It's shipped every week. And that means that security is something that can't just be tacked on at the end, but needs to be integrated into the code development lifecycle. So that's where DevOps is talking about bringing in agile performances to code development, so that it's not something that takes a long time, but it's something that can be built in a more continuous deployment process. And then DevSecOps talks about how we can build guardrails around that to be able to not have it be kind of a gatekeeper that has to approve everything and add additional delay to what developers are trying to do. So really the challenge here is, how do we redesign the security function to fit into Agile? And of course, this is something that not just is relevant for blockchain, but it is relevant for the broader space too. If you're interested in learning more about this, actually just yesterday, Google announced a report. It's called the State of DevOps. It's released every year. It's really interesting to hear about how the broader tech ecosystem is dealing with DevOps. And today, of course, we'll be focusing on blockchain. But if this is something that you're going to be doing, deploying contracts, securing them continuously at launch, definitely encourage you to check that out so you can bring in the best practices. So with that, with a rough understanding of what DevSecOps is, let's talk about how it relates to blockchain. So first and foremost, when DevSecOps meets crypto, we have to recognize that rapid growth and experimentation is pretty core to everything happening in the blockchain space. The entire space is less than 10 years old in terms of the applications we're talking about today. And in that case, even the applications that are considered mature today, like L1s, they constantly have their own development plan, and a change in the L1 ripples up to L2s, ripples up to dApps, ripples up to all the applications that we're building. So really, I think speed is at the crux of something that crypto is embracing, and that also means that security doesn't want to be the one thing that slows it down. I think that's what even the previous two speakers have been talking about. So while that's the premise of the blockchain space, when we actually look at how applications are being deployed today, generally it's still following what is the previous model, which is folks spend a long time building, and then it ends up into this code freeze of a month, 2 months, waiting for the right auditor or multiple audits. And then once the auditor signs off on it, it's like mainnet ASAP, launch it, and then start growing pretty aggressively. So there's this tension between wanting to go fast and then not necessarily having the security systems and processes built to do it in a continuous manner. But then in the meantime, we're still doing kind of the initial version of this. So that's kind of one tension that we've been noticing across the teams that we've been working with. It's even harder because once a contract is posted, most times it's immutable on the blockchain. Of course, upgrades are a caveat to that, but upgrades themselves have their own challenges. But with smart contracts being infrastructure that's being pushed, being completely immutable, it can be very challenging to launch and come back and make changes to the system. To add to this, of course, it's a very challenging thing to do correctly. And if you look at some of the accidents that have happened in the DevSecOps world, it's not uncommon with even the biggest projects in the crypto space. There's like 3 images right here. The first one is from Compound having 162 million that was stuck because of a bug upgrade. Second one is from Wormhole, which had a contract on chain that wasn't initialized. All the attacker had to do was just initialize it, set themselves as an owner, and then go ahead and take over that contract. And then after that was also Aave that was doing an upgrade and had over 100 million. So that's some of the biggest projects in the space. All 3 are like 9-figure hacks. So this shows you that it's a very core part of what it means to build a successful protocol, but also when done wrong can lead to quite a few different accidents. The third one, which I want to touch on here as to why DevOps is relevant for crypto, is actually in the exploits world. So of course there's the speed angle and there's the accidents, but even for exploits, having good DevOps can really be a huge game changer. First of all, the attacks we're seeing today are existing in what we're calling attacker kill chains. So it's very rare that it's purely a single transaction. We usually see some level of reconnaissance, configuration, funding, the actual exploit, and then multiple different steps before and after the hack transaction. Of course, this may change as things move on, but today this gives us the chance to be able to have the right systems in place to be able to stop this at any different point in the life cycle, to be able to stop the kill chain. So that's really exciting to think about how DevOps has that potential. Additionally, with one of the teams that we've been working with, we actually set up some monitoring for them to be able to identify, what was happening with the tokens in the broader blockchain, and we identified that there was some tokens being traded on FTX, then unexpected EOA that they were able to, using DevOps and monitoring, identify, pull those tokens out, and this was before kind of those tokens would have been frozen under the FTX kind of situation that ensued afterwards. So that was a huge win for them to be able to have the right monitoring in place. Then additionally, one of the teams that we work with also, they were able to set up a PagerDuty call so that when a major pool imbalance happened during Terra Luna, they got a call on a Saturday and were able to kind of emergency move some funds out. If they didn't get that call, they would have been 100% exposed. And with that call, they were only 20% exposed. So not an absolute get out of jail free card, but really the ability to limit the damage and be able to kind of help teams in critical situations. So that's setting up some context for why DevOps is important. And of course, as a blockchain industry, we don't want to give up the speed. We don't want to have accidents, and we definitely want to have better tools in the chance of exploits. So let's talk through how we can integrate DevSecOps into the workflows that we're all building today. And with DevSecOps, I just want to call out that it's not necessarily like a simple tool or a plugin. It's not a linter or a code analysis plugin. It's more of a framework. And that's where it becomes really interesting to think about how it's applicable across every stage of the protocol. We've been seeing this in practice with quite a few different teams that we work with. And I broadly have been able to see it in 4 key areas. The design, code, transactions, and protocol is how I've been thinking about it. So right now, let's dig into each of these and really understand how DevSecOps is implemented in each of these different phases of the protocol. So when it comes to design, this is actually where a lot of us start when we come up with a project, either a hackathon or some of the biggest projects today started off with just an early design of what it could look like. Of course, that design involves mechanisms, tokenomics, and key application flows. But one of the core parts that touches DevSecOps is a threat model. So when it comes to threat model, this is essentially what we would call expecting out scenarios. A threat model talks about the scenarios being both like good and bad scenarios, and speccing out who the stakeholders and interactions are. Here's a quick kind of mental model I wrote out that you can use and spec out who the users are going to be for your contract, whether it's which dApps would they integrate with, if it's hosted on a Web2 infrastructure, what would that look like in terms of the different APIs and providers, which wallets you'd want to support and integrate with, blockchain smart contracts in terms of how many and what configuration you do there. And then, of course, what admin functionality there would be across the whole team. So those are just it's a very high-level version that I just put out here. Maybe even the starting point for some of you all. But I just wanted to point out that as good as application design is, I think threat model is something that's the first step of DevSecOps for any contract. Next, definitely, early on integrate logs, pre-design some testing scenarios, and come up with these invariants that you want to test. For DeFi teams, this may be over collateralization. For NFT teams, it may be some level of liquidity or some invariants around their order book. But definitely think through logs, testing, and invariants for your application. And what some of the best teams have done here is actually limit the area of the code base that they expect to work perfectly. A good example here would be if you look at Uniswap's core and periphery contracts, and you're welcome to go check that out. What they've done is with core, it's very simple, almost like too simple, but that's kind of by design to make sure that there's very little scope for anything that could go wrong, very limited chances for exposure to happen there. And that way, periphery is where they can do all the interesting experimentation with user accesses, interfaces, and APIs, while core continues to be like the part that's battle tested and secure. So that's a really good approach that we've seen some of the best teams in the space too. Of course, even with this, it's really important to stay on top of the protocol changes that keep coming out. So definitely, review EIPs and standards as they're happening. I think when, the gas optimization EIP came out, 4337 came out, a lot of these EIPs have been really kind of conversation inducing in the whole space. And I think that's why it's really relevant to make sure that you're not ending up with that incompatible with the existing EIP protocol. And the last thing I want to say here is it can be very frustrating if you're doing 9 out of 10 things right and one of them goes wrong. So really, it's important to be very consistent and continuous here. There's a couple of examples I can point out here, but the idea here is, if you get 3 or 4 audits and you have a really strong developer team, but the process is not great. You have a locally deployed 3 of 3 multi-sig all in one place, or you have a developer pushing code directly from the laptop, and the laptop has malware. All the hard work you're doing on the smart contract side or even on the testing side can go to shame. So definitely be consistent across the entire stack, because that can actually be where vulnerabilities can creep up. So that's on the design. Talking through code, which is where I think a lot of us are going to spend our time. First and foremost, it's before you start building anything, really start with battle tested contracts where you can. This is where OZ's contracts like the ownable, initialization, utilities, these are amazing because they not only save you time, but they also save you vulnerabilities. These are battle tested and definitely where you want to begin if you're going to be building some of the more kind of templated versions of contracts. Definitely where I like to start if I'm going to be experimenting with any of the smart contract flows. When it comes to deploying a contract, fork testing used to be very hard. I remember trying to do this 3 years ago, but today it's much easier to do using things like Foundry or Hardhat. And the idea here is, any contract that you want to deploy, you can check contract state and account state before and after using a mainnet fork using Foundry or Hardhat. Not that high lift in terms of work, but extremely high impact to know that there's no unexpected changes happening in terms of integrations. I'm looking at time, and I think I might need to speed up a little bit here. But there's code security testing, which I think is really relevant and can save you a lot of pain. A couple of really awesome libraries put out by really smart auditors, like Mithril, Slither, and Kidna, which I recommend you check out. Dependency monitoring, which has come up in a lot of hacks recently. Not knowing that you forked a vulnerable version of a contract can be, quite an area of demise for some projects. So here, there's tools like CodeSlaw that have verified contracts, or Pinata that give you a bunch of different verified contracts too. And using those, you can make sure that any contracts that you're including are battle tested and don't have dependency risk. And of course, if you're using an audit, make sure that your deployed code doesn't stray too far from that audited code. If it is straying far, then just maintain that diff very carefully and go ahead and revise that very continuously. I'll speed through transactions. I think transactions is really interesting since it's both as a user of a protocol, but also as your protocol interacts with other protocols. There's going to be a ton of best practices that you should be considering when it comes to transactions. First one's being testnets. I think it's fantastic to see all the infra that the entire community is building around testnets. Ourselves, we've actually at Guardrail implemented a bunch of testnet support, and our teams that are launching really large mainnet projects will spend months on testnet, just creating bots and simulating test cases. So cannot say enough good things about using a testnet to verify the protocol is working correctly. Investigation tooling, of course, you're welcome to use Etherscan, but you might want to think through some possible scenarios that come up and be familiar with tools like Breadcrumb, TokenFlow, and a bunch of other investigation tooling. I have my own stack, and I'm happy to share if you're going to go down deeper down that route. A specific monitoring for transactions, I think this makes a ton of sense when you might want to think about what are cases that you want to be alerted about. So this could be bad sources of funds. It could be an unexpected contract that just got posted, funded by a tornado that you want to know about. So there's a couple of these specific scenarios that maybe don't happen as often, but if they happen, you do want to know and be able to kind of get a chance to react. So this is where you can spend some time designing those and using real-time monitoring platform. And then early on, set some limits and expectations for your own transactions. This is helpful too, since as you launch, you might want to create your own definitions of what a whale transfer is, what MEV looks like, or maybe even roughly some expectations of what hourly or daily contract interactions look like. And this can make it clear when maybe front running or exploits are about to happen. I'm just going to double check that my audio is still working all right. Awesome. Yeah, and then I think touching on protocols, which is I think where we spend most of our time, definitely with design code and transactions, it's where it all starts. With protocols, that's where we're able to really work closely with our teams to build in DevSecOps and then obviously build in monitoring for them. Definitely feel like this is where stakes get higher. There's more operations, more chances for failures, and a lot more moving parts. So first and foremost is really to be able to track and defend your own protocol's perimeter and also the internal moving pieces. So this means really understanding what are the Web2 API keys and what privilege each of them has. On the Web3 side, which external dependencies are there, whether it's oracles or price feeds, or just making clear, how often you'll be doing upgrades and things like that. Of course, on the internal side, we've seen this also put us a couple of teams in trouble, whether it's like tech permissions or malware. So these are all things that I think are really relevant for a protocol to keep an eye on when it comes to DevSecOps. Next, it will be actually standardizing key workflows around some of the more operational pieces that, as we saw earlier, could be places where things go wrong. Deployment, upgrades, and initialization are three that come to mind. Additionally, building in multi-sigs for admin or high privilege actions is a really good idea. And of course, these multi-sigs should be people that are able to piece out what is authorized versus unauthorized. But this could usually be like the tech lead and one or two other folks. But I think the multi-sigs are a fantastic idea to re-implement at the protocol level. Of course, we're all hoping this doesn't happen, but in case something wrong does happen, definitely be prepared. Have an incident response plan with a clear point of contact, a clear list of who, based on criteria, who gets invoked and pulled into a war room. It's really helpful to have controls in place to begin with, so that in case you do need to take action on pools, you can go ahead and do that. And then, of course, some documentation and data to be able to jump into any investigations. And of course, all of this might be a lot to do, and that's where I think these tools can be really helpful to monitor what's happening. The question I like to ask a lot of teams that are really on the way to growth is, if there is like 100 ETH transfer or a proof of concept that's hosted on chain, would you get to know that this hack just took place? Because I think it's really important that you're at least able to detect them. If not, go ahead and take some actions based off of that. Case in point, if you look at some of the largest hacks that have happened recently, most of them were detected by other folks, security researchers on Twitter, which is never a good look for a project. And then when it does happen, it's also takes quite a long time to triage comms. So getting ahead of this is something that the whole industry is learning, but I think extremely vital to be able to do. Looking at the time here, I think I'm coming up. So really quickly, just some concluding thoughts here. I think as an industry, we're getting a lot more aware about security. I remember in 2017, it used to be the case that audits were optional and maybe insurance was part of the conversation. Today, it's mandatory that everybody's looking at best-in-class security tooling when they're launching. I think customers are demanding it and protocols are bringing it, and that's just awesome to see around the whole space. And including that too, I think the whole industry is getting a ton of practice with incident response, which is really getting the whole space a lot more mature, which is really exciting to see. I think I'm at time, so I hope you found this talk interesting. If it was, reach out to me on Telegram and happy to continue this conversation. Thanks for attending.